All right, guys, so today for 6B, we are talking about measures of variation, which tells us how spread out data is. So if you look at these two graphs, it says that they're waiting times. So I don't know, maybe this is the line at a restaurant or something. And on the left, the waiting times go from 4 up to 11. But on the right, if you notice, the waiting times are all bunched around 7 and 8. So when we talk about variation, we're talking about how spread out the data is. And looking at the graph, it's easy to see the data in the second chart is really clumped together. It's all either 7 or 8. The data on the left chart is spread out between 4 and 11. So it's a lot more varied. It's a lot more spread out. Now, back in clear back in elementary school, the first measure of variation you learned about was range. So remember, range is where you take the biggest number in the data and you subtract the smallest number. So I would take 11 minus 4 and get 7 on the left. On the right, I would take 8 minus 7 and get 1. So those are measures of variation. That's what the range is. It's called a measure of variation. It's the most basic one that you learned, but it doesn't always paint an accurate picture. In this case, it does. It tells us that the data on the left is way more spread out than the data on the right. But sometimes it can be a little bit misleading. So if you look at these quiz scores, for quiz 1, one person got a 1 on the quiz. Everybody else got a 10. But if you look at quiz 2, you've got a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, and a 10. So if you were only looking at the range, if that's all you knew, for the first quiz, you would do 10 minus 1 and get a range of 9. The second quiz, you would do 10 minus 2 and get a range of 8. It looks like the data in quiz 2 is closer together than the data in quiz 1, which isn't true. Quiz 1, most of the data is right grouped together. There's just this one outlier that really messes up your range, okay? So we needed to come up with better ways of measuring variation. We couldn't just rely on range because obviously that doesn't work all of the time. It's a good idea, but it doesn't always give the best picture. So you got out of elementary school, you went to 7th grade, and you learned about quartiles and what's called the 5-number summary. I'm not going to spend a lot of time today on the 5-number summary because this is something you have done since 7th grade. But to review what it means is if you take all of your data and put it in order from smallest to biggest, then you kind of break up your data into what are called quartiles. So you start by finding the median, the data that's right in the middle, and then the upper quartile is the data point that's in between the median and the highest value, right? Because 11 over here, that's our high point. The upper quartile is in between the middle and the highest. The lower quartile is in between the middle and the lowest value. And then, of course, you have your lowest and your highest data point. So we call this the 5-number summary. And then we represent this a few different ways. One of the ways that we do this is we just write it down, lowest, low quartile, median. So I would say, well, my lowest is 4.1, my median is 7.2, my high is 11, and then in between the lowest and the median is 5.6, and in between the median and the highest is 8.5. So that's one way we represent the 5-number summary, is we just make it in a list. The other way that you did it in 7th grade was with a box and whisker plot, right? So in this picture, it kind of gives you a visual representation of the 5-number summary. In the middle of the box, you have the median. So there's your median. At the end of your whiskers, you have your high value and your low value. And then you've got this box in the middle. And the box goes from your lower quartile to your upper quartile. All right. Now, all this does is it just takes those values, it puts it on a number line, and it gives you a visual representation of how much the data is spread out. Okay. We're not going to spend time practicing this right now, but it is something that you need to know how to reference and how to use, okay? I believe on your homework, it's going to ask you to do a couple 5-number summaries, but I'm going to show you a different way to do those. In the past, so if we have this example right here, race times. So it gives us a set of race times, and it wants us to give the 5-number summary, okay? That could take a lot of work. Nicely, they already put it in order from smallest to biggest. So we have our smallest, we have our highest. It should be pretty easy to find the middle number from there and the quartiles. But we can also do that on our calculator. So I already took these numbers and I went to my calculator and I hit the stat button. It's right, if you go to the right of the alpha, the green button, there's a button that says STAT, stat. If you click on that, you have 3 options: edit, calculate, across the top, and test. We want to edit because what we want to do is make a list of numbers. And if you notice right here, I already made a list of all of those numbers, okay? So there's 20 of them, and I put them in list 1. If I wanted to make another list, I could go over here to list 2 and just start plugging in numbers, whatever I wanted to do, okay? So I put all of my numbers in list 1, and then I go back, I hit stats again, but this time I want to analyze those numbers that I put in there. So if I go over to calculate, my very first option says 1 VAR stats, 1 var stats. And if I hit enter on that one, it asks me for a few things, like what list I want to use. Well, I put all of my data in list 1, so I'm going to leave it as list 1. Frequency list, we don't really need to worry about that one. I'm just going to hit enter. And if you notice, it's kind of a little bit goofy on my screen, but if you notice over here on the right, it gives me all of this data, okay? So let's talk about what this data represents. This X at the top, my picture doesn't have the X. It should have a little line over the top of it. It just doesn't show up on my calculator for some reason. That gives me my average. It says my average, my mean is 10.1335. So if we go back to the page here, they've already done the data as well. So if I look at my set of running times, the median is 10.135. Sorry, not the mean. It gives me the median, the middle point of my data. Okay, so if I go back here, it gives me my middle point. Now, as I scroll down, this SX, we're not going to talk about that one yet. N tells me how many data points it gives me. It gives me my minimum. Minimum of X is 9.92. The median is 10.135. The maximum is 10.38. And then it also gives me my quartile 1 and quartile 3. So maybe this first one does give you the mean. It just happens to be really close to the median. In this case, like I said, that first number should be your average, this one right here at the top. But down at the bottom, you get your 5-number summary. Minimum, quartile 1, median, quartile 3, maximum. So all you have to do is plug the list in your calculator, go to stats, go over to calculate 1 var stats, and it will give you all of these numbers. It'll find those numbers for you. Okay. It also finds the average, which you just saw, which was 10.133. Now, the new thing that we're going to use, so that's something that you've already done. You can transfer that to a box and whisker plot. We're not going to spend time doing that. You just need to know this year it's a lot easier to find the numbers. Just plug it in the list. We have a new measure of variation, and probably the most accurate measure of variation, and it's called standard deviation. Okay. Now, finding the standard deviation by hand is miserable. It takes a lot of work. It takes a lot of steps. Basically, what you have to do, if you notice this, it tells you in this list what to do. First of all, you have to find the average of the data. You have to find your mean. So I would have to take all of this data down here and find the average. Then you have to take each point of data and subtract it from the average and get a new number. Then you have to square that new number. Then you have to add all of those numbers together and then divide by this formula right down here. Then you divide by the total number of data values minus 1. Then you take the square root. There are so many steps to finding the standard deviation. We don't expect you to do that by hand. You could, if you really, really want to, you can follow these steps, take a screenshot really quick, follow those steps, or we just use our calculator to find the standard deviation, okay? So this one wants us to calculate the standard deviations for the waiting times, and it gives me two different lists, right? So we've got this list and this list. So if I go to my calculator and I go back to my lists, I hit edit. So I hit stat and then I go to edit. I want to delete everything in my list. So I'm going to go ahead and delete this list. I don't need it anymore. So for list 1, my numbers are 4.1, 5.2, 5.6, 6.2, 6.7, 7.2, 7777. I know this is so much fun listening to me read out numbers, huh? So I'm just taking all of that data and I'm putting it in my list. So that gives me what? 12 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points, not 12. Okay. So if I put all of those numbers in my list for list 1, then I hit stats again. And instead of edit, I go over to calculate and I do 1 var stats. Enter, enter. Down here at the bottom, if I scroll down, I've got my minimum 4.1, my median 7.2, my maximum 11, my quartile 1 and quartile 3. So there's my summary, my 5-number summary. At the top, I have my average, my 7.2. But there's this weird number in the middle. It's this great big capital S with an X. That is your standard deviation. Okay, that S stands for standard deviation. So rather than doing all of that arithmetic, plug the numbers in your calculator in a list, click 1 var stats, and all you have to do is find this number. Oh, where'd it go? I'm not sure what's going on right now. You find that SX. So in this case, it would be 1.96 would be my standard deviation. Okay, that would be my standard deviation. You are welcome to do it by hand if you really want to, but it's ridiculous. Just know that what you're getting yourself into. If you are using one of my calculators, this is on my calculators. If you are using a different calculator, bring it to class and I will show you how to find the standard deviation using whatever calculator you have. You should be able to find that without having to do all the nuances of doing it by hand, okay? So, that's standard deviation, super easy. The last thing that we need to talk about is the range rule of thumb. All right, so we can approximate the standard deviation. We can't find it exactly, but we can kind of get an estimate of what the standard deviation is by using the range. So what we do is to estimate the standard deviation. Notice how it's not an equal sign, it's the little squiggly line. That means the standard deviation is approximately, you take the range and you divide it by 4. Okay, we take the range and divide it by 4. So for example, this data that we just used right here, the range was 11 minus 4.1. So what is that, 6.9? So I would do 6.9 divided by 4, which gives me what? 6.9 divided by 4 is going to be 1.725. So approximately 1.725. Now that's not exactly my standard deviation. I just found that my standard deviation was 1.96. But it's an approximate standard deviation, okay? And that approximate is very important when you're doing this. It is not exactly right, it's just close. So if we know the range, we can approximate the standard deviation, which can kind of help us find what our mean would be. So let's look at these examples right here. Use the range rule of thumb to estimate the standard deviation for the waiting times. Well, we just did that for the first one, right? We just found that our waiting times, that was this first list that we just did. So let's do it for the second group. My range, 6.6 and 7.8. So whoops. Let's go down here. We're going to do 7.8 minus 6.6 is going to be 1.2. And if I divide that by 4, then my standard deviation is approximately, what, 0.3? It's not exactly 0.3, it's approximately 0.3, okay? You can also use the standard deviation to estimate the range, because if you noticed, when we used this estimation, we divided by 4. So basically, we took our lowest number and our highest number, and we split it into 4 equal groups, right? Which means that our mean should be right in the middle. Not exactly, but it should be in the middle there somewhere. So it wants us to, we have a mean of 45 miles per gallon, and we have a standard deviation of 4 miles per gallon. Estimate the minimum and maximum. Okay, so if my mean is, what was it, 45? Is that what my mean was? Yeah. If my middle value is 45, and it wants me to estimate my high value and my low value. So the distance from the mean to the high value is about 2 standard deviations. So what that means is from 45 to my upper quartile is about 1 standard deviation. Well, my standard deviation is 4. So this distance right here is about 4, which means from my quartile to my high, that distance is about 4. Now, again, we are estimating. It is nowhere near precise. It's an estimate, okay? From my mean going to my lowest, each standard deviation is 4. So this would be 4, and this would be 4, right? Because I took my data, I split it into 4 groups. That's why I have 4 parts. That's not why my standard deviation is 4. My standard deviation is a value of 4. What that means is my lower quartile is at about 41, and my upper quartile is at about 49. So my high value is about 53, and my low value is about 37. Approximately. This is an estimate. It is nowhere near precise. So remember that if you start trying to do math with these numbers. All right? Okay, so homework 6B, mostly calculator work. You are plugging numbers into a list on your calculator, hitting the 1var stats button and letting it do all the math for you. You just have to take the data, pull it out of your calculator, and put it in the right place.